All right, I hope you're doing well today. So we're going to do section 12.4, and we're going to start a tiny bit of 12.5, just like the first page or two of the notes, just to get them out of the way a little bit. So in class we talked about how to do the determinant of a 3x3 matrix, and we did it using what are called cofactors. But anyway, just to start off here, the determinant of a 2x2 matrix, remember you have to crisscross these things, and so the easy way to think of it is like that. So you do these 2 times 5 is 10, minus these 2, well those 2 multiplied is a -3, so 10 minus -3 is 13. So when you do the cross product of two vectors, that involves kind of the determinant of a matrix, but it's a 3x3 matrix. So what you do is you put I, J, K across here, because the cross product of two vectors is a third vector. It's not like the dot product where it just comes out to a number. The cross product of two vectors comes out to another vector. So I'm going to put, since this one was first, 2, -1, 3, that has to go first, and -4, 0, 1. So you put your little determinant lines around there. Now, what I'm going to do, if I want to get the first part, or the x part of the cross product, I cross off the row with I and the column with I. And so that leaves me these other 4 numbers right here. I'm going to do the determinant of those 4 numbers like we did up in the example where we got 13. So if I do that, I'm just going to hold this here while we talk about it. So if I do that, I get -1 times 1, so I get -1 minus 0, because 3 times 0 is 0. So -1 minus 0 is -1. All right, so I get, for my part, I get -1. Now for the second part, the y value, or the j part, I cross off the row and the column with j, and then I have these 4 numbers to do my determinant with. So 2 times 1 is 2. 2 minus, and the other side is, other way is -12. 2 minus -12 is 14. But for the center number, you have to do the opposite of that. So since I got 14, 2 plus 12 basically is 14, then I'm going to write -14. And for the third one, you guessed it, I'm going to cross off the k row and the k column, which gives me these 4 numbers. So I get 0 minus 4, so I get -4. So the only trick is, when you do it, is this center number right here is the opposite of what it really is, what it was before. So this right here is another vector. I could have written it in component form like this, or I could have written -I minus 14j minus 4k. You could write it any way you need it. All right, so what does the cross product find? So the cross product finds a third vector that is perpendicular, and another fancy word for perpendicular is orthogonal. Probably has some kind of physics meaning or reason for that. That is orthogonal to both of the original 2 vectors. All right, so take a second and look. If I had done the dot, how do you prove things are perpendicular? You do the dot product, right? If I had done the dot product of, say, this and this, look at what that would be. I would get 4 plus 0 minus 4. Hey, guess what? 0. The dot product of this and this, I would get -2 plus 14, so that's 12, and then 3 times -4 is -12. I got 0. So that kind of proves to you that it's perpendicular. So this is going to be important later in our when we talk about planes, but this is a picture of what a cross product does. So you have 2 random vectors, you got A and B, and then the cross product, and the A and the B don't have to be crossing. They could be like on like planes that are like not crossing each other, and you find a third vector that is perpendicular to those two. So the third vector, and I'll show you more like in class when I can use some like little sticks and stuff, but anyway, this is your third vector, your cross product. It is perpendicular. It has a right angle with B and also holds a right angle with A. Okay, and again, A and B don't have to intersect. It's just an easy way to show you. All right, so just be careful when you're doing the cross product, the order matters. All right, if you had A cross B and you did B cross A, these would come out the opposite directions. So like if we had done B cross A in the last example, we would have gotten 1, 14, 4. We would have gotten the opposite direction vector. So B cross A and A cross B are not equal to each other. One of them is the opposite of the other one. Okay? All right. Now at times it doesn't really matter that much, like if you're talking about a direction and using it for a plane like we'll talk about, but anyway. All right. So some formulas that you have down here, and these, I mean, you know, you get to use a formula card when you take a test or quiz. Frankly, these days, since we're virtual, you get to use your whole book and all your notes. So, anyways, you know, if we're ever back in class, you can write any formulas down on a 3x5 card that you want. So you don't have to memorize these things. But just if you want to find the angle between two vectors, this is now another way to do it. If you move the A and B to the other side, it turns into this. All right, so these two come up every once in a while. The magnitude of the cross product is the area of the parallelogram with vectors A and B as two of its sides. So let me use this picture again. So forget about this guy right here. If you had these two vectors and you see how you have a parallelogram. So if you did the cross product and did the magnitude, which is actually written right here, that would be the area of this parallelogram. And guess what? When you take half the area of a parallelogram, half of a parallelogram, oh that's ugly, take half of a parallelogram and you got a triangle. So if you want a triangle with those two, I guess I should have marked this triangle, not that one. You got a triangle with those two A and B as its sides. Okay, so that's what this number 3 is. 1/2 A cross B magnitude is the area of a triangle with A and B as two of its sides. And if your cross product comes out to 0, guess what that means? Then your vectors are parallel. All right, so that's another way to prove things are parallel if you like. The easiest way is just that they're scalar multiples of each other. So make sure you kind of look up on this page in your online book, and it says a little 8 in that little theorem box. Those are just some rules and theorems about cross products. They're not that big a deal, but there's things to kind of watch out for. All right, so then we have something called a triple product. A triple product is defined as this little piece right here. It's when you have 3 vectors, it's a scalar triple product. If you have those 3 vectors, and those 3 vectors basically meet up at a corner right here, so they meet up this corner over here, and this little shape that you would draw for this is kind of like a 3D parallelogram. It's called a parallelepiped. So say that a couple times fast, a parallelepiped. All right, and so what it does, if you were to calculate this triple scalar product, it's going to be the volume of a parallelepiped that is formed by those 3 vectors. You know, so it's basically like a 3D format of the parallelogram area. And so, but when you do this triple scalar product, you have to take the magnitude of it before you finish off. So your volume is going to be the magnitude of this scalar triple product, A dot B cross C. And it turns out, since you're doing the magnitude, it doesn't really matter which one's A, which one's B, and which one's C, but we'll just take it how it is and do the formula for that. Okay? All right, so the worst part is to do the cross product. So we're going to do B cross C over here. So why don't you take a second and do B cross C yourself and come back and see if you got it right. All right, so B cross C, you should have an IJK. B was 4, 1, -1, and then 0, 6, 1. All right, so if I do my cross product right there, if I cross these two off, that right there gets me 1 plus 6, so that gets me 7. Then if I cross off the center in here, that gets me 4 minus nothing, so 4. But I changed my sign. And then the next part, let's see, cross that and that off, so that gives me 24 minus nothing, so just 24. So hopefully that was your cross product. And so I have to dot that with A. So I'm going to take negative 2, 3, 0, dot that with 7, negative 4, and 24. So luckily the 24 is multiplying by 0 because that's annoying. All right, and so my volume is going to be negative 14. I have to do the magnitude of this. And so you'll see in a minute that yes, it's a magnitude, but in a way it kind of means absolute value because we're not getting a vector here anymore. So I have negative 14, let's see, plus negative 12. I guess I misspoke earlier. Sorry about that. So volume, absolute value of 26 negative, so 26 units cubed. All right, so it'd be the volume of that kind of like squished parallelogram, right, or prism. All right, so the last little thing in this section is about torque. So one use of cross products in physics is to calculate torque. So you have a little picture over here. So this is a wrench, and you're screwing this bolt right there, or you're turning that right there, and then you are pushing down with your force vector right there. And torque is a tendency of a force to rotate an object about an axis, fulcrum, or pivot, in our case the origin. The torque, that little, probably called a tau, but I'll just say T, is defined to be the cross product of the position and the force vectors. So that's your torque. So the direction of the torque indicates the axis of rotation. The magnitude of the torque vector is this. So it's basically the magnitude of the cross product. And so this is pretty much kind of like that formula you saw earlier. But anyway, if we want to calculate torque, we're going to do that. So here, a bolt is tightened by applying a 40 Newton force. So this is going to be my force right there, to a 0.25 meter wrench. So that's going to be my R, because that's how long the wrench is right there. So that's going to be this, right? As shown. And find the magnitude of the torque. And so what's shown here is that the force is being applied at 75-degree angle down. So it's going to be my theta. All right, so my magnitude of my torque is going to be my R times my F, so 0.25 times my F, which is 40, and sine of 75 degrees. All right, so go ahead and you pop that in your calculator. You get 9.66, and that was in newtons and meters, so Newton meters. Okay, so if it's not in meters, like if it's in centimeters, you should change it to meters, because that's like a more common notation there. And if it's in feet, you would answer in foot-pounds. That would be your torque right there. All right. All right. So like I said, I'm going to go ahead and start section 12.5. And just to do like the first little two pieces right here. So think about a line in 2 dimensions. What do you need to know to be able to tell how the line goes or where it is? Right? So tell me that in Edpuzzle. How would you know, how do you tell me like where a line is and what direction it goes and things like that in 2 dimensions? All right, so hopefully you said you need some kind of point that it goes through, or some kind of place to like ground it in a way, and you need its slope. You need like the direction it travels. So for 3D, you need similar information. You need a point. So we're going to call that x1, y1, y1, and z1. All right, and you need some kind of direction vector. So my direction vector is kind of acting like my slope in a way. So when we do that, we're going to call that A, B, and C. So notice the little pointy brackets on that, not the parentheses. All right, so there's going to be different types of equations that you can use. And so we're going to use 2 of them. We're going to use parametric, You might have heard parametric equations in physics, and you might have heard of parametric equations in pre-calculus, but this is where like the x, the y, and the z motions are separated into like 3 separate actions or 3 separate things that act together. So parametric form of the equation of a line is x equals x1 plus at. So t is like your is your variable that is in all of these things that's just going to stay there. So we'll show you in a minute. So y equals y1 plus bt, and z equals z1 plus ct. So what's going to happen is you're going to take your direction vector and it's going to go along here with each t value. So in a way, it's kind of like your slope, like in, like in y equals mx plus b. X is kind of like the t here, where it's just going to stay next to your slope, and the x1, y1, and z1 are just going to sit right there. Okay. All right. Then tell me in the ed puzzle, all these equations, I could solve them all for what letter that would be the same for each one. All right, so hopefully you said t. So I want you to imagine solving each one of these for t. For instance, if I took this one and solved it for t, I would get x minus x1 over a. If I solved the second one for t, I would get y minus y1 over b. If I solved the last one for t, I would get z minus z1 over c. Okay, so that is another format of an equation of a line, and that is called symmetric form. Okay, so it is x minus x1 over a, y minus y1 over b, oops, not equals, and z minus z1 over c. All right, so in a way you can let yourself know these are all equal to t. All right, so if you ever needed to use that. All right, and so we're just going to do a couple last little things on here. Let's just do, let's see, we'll do this first example and then we'll be all done. So find the parametric and symmetric equations of the line that pass through this point and is parallel to the vector 2, 4, -4. So when something's parallel to something else, that means that's its direction. All right, so I could actually use 2, 4, -4, or I could use 1, 2, -2. I could use some other vector if I want. That's just telling me the direction to go. All right, and so there's a picture of it over here. So here's the point 1, 2, -2, 4 right there. All right, and then this vector right here is the direction I'm going to follow. So what I'm going to get is I'm going to get an equation of a line that takes me the same as that blue line, but it's going through this point. That's what this equation of this line is going to be. All right, so go away. Oh my gosh. So the parametric form. Okay, so parametric form would be x equals, y equals, and z equals. So I take x1, so the first part of the point, so 1, and then plus whatever my a value is right here, so plus 2t. All right, and then y equals, so y would be -2 plus 4t, and z would be 4, and then the c value is -4, so I'll put minus 4t. All right, and then if I was doing symmetric, I can, in my mind, solve all these for t and just write that, or I could use my formula on the other page. I do x minus x1, so x minus 1 all over 2 over y minus y1, which is -2, so it turns into plus 2 over 4, and then z minus 4 all over -4. Okay, and so we're going to leave the rest of this for in class or next time, and that'll be it.